Good morning, my YouTube viewers. In this particular video, what we're going to be talking about is nonlinear regression, whereas in the previous two videos, we discussed linear regression, being simple linear regression and multiple linear regression. So nonlinear regression captures relationships that cannot be accurately modeled using a straight line, such as exponential or polynomial relationships. And so what we're going to do in order to demonstrate nonlinear regression, we're going to write a program in Python to do that. So in order to write this program, the first thing that we have to do is we have to import the libraries that we're going to need to execute the program. So the library that we're firstly going to import is NumPy SNP, which is the numeric library. And then we're going to import matplotlib.pyplot as PLT, which is the visualization library. And we're going to import from scipy.optimize, import curvefit. And scipy is Python's scientific library. So then what we need to do is we need to set up our example data. So your X values are your independent data and your Y values are your dependent data. So X data equals an NP array for a number from 1 to 9 and integers from 1 to 9. And your Y data is a NumPy array from various numbers as well. That's not from 1 to 9. And then so what we're going to do is we're going to define the linear function, which is quadratic, to fit the data. So def nonlinear func brackets x, comma a, comma b, comma c, colon, return a times x squared plus b times x plus c. So that's the formula for the quadratic equation. So we're going to fit the nonlinear function to the data using the curve fit. Initial guess equals brackets 1, 1, 1. That's the initial guess for the parameters. Params, comma, covariance equals curve fit, brackets, nonlinear func, comma, x data, comma, y data, comma, p0 equals initial guess. So we're going to extract the fitted parameters. A, comma, B, comma, C equals params. And then we're going to print the fitted parameters. The quadratic coefficient is A, the linear coefficient is B, and the constant is C. So we're going to print those values out. So the quadratic coefficient is 1.06, the linear coefficient is neg 1.83, and the constant is 3.47. So now we're going to generate predicted values using the fitted model. Xfit equals np.linspace, brackets min x data, comma, max x data, comma, 100, and then yfit equals nonlinear funcs, brackets xfit, comma, a, comma, b, comma, c, and then we're going to visualize the data. So plt.figure, brackets fig size equals 6, comma, 4, and then we're going to create a scatter plot of the original data. So plt.scatter, brackets x data, comma, y data, comma, color equals blue, comma, label equals data points. And then we're going to plot the nonlinear curve. plt.plot, brackets xfit, comma, yfit, comma, color equals red, comma, label equals fitted curve nonlinear. And then we're going to add labels, title, and a legend. And then the title is nonlinear regression quadratic fit. The X label is X data. The Y label is Y data. And you've got the legend, and then you've got the grid. and then we're going to show the plot. So this is the plot that we have created. It's a nonlinear regression, quadratic fit. So the blue points are the data points, and the fitted curve is the nonlinear curve that's been created. And you can see that for the most part, the blue dots are actually on the data points, so it fits it quite nicely. So this concludes the video on nonlinear regression, and the next video is going to be on logistic regression. And so I hope you decide to watch it.